Hi everyone, and welcome to Makers Machining again. We've got a special episode today for you. We're going to talk about measuring. How do you measure up when it comes to machining? Well, that's kind of a new thing for a lot of people when they're first getting into the trade. How do you keep track and measure your parts that you're making? Everything that you do with your measuring affects the final outcome of your part from the very first cut that you make. If you're cutting a piece of material off with a saw, you'll probably use a tape measure. So what I'm going to suggest right now is if you want to put this on pause and go and grab a tape measure, get one in your hand if you have one, and we'll see how this thing measures up and how it works. And I would also ask, share this with some of your friends if you're in a math class or a shop class, or you're working and you need a little refresher on measuring. We'll be dealing with that today. Tape measure is going to be the starting point. Make sure to subscribe and share this with some of your friends. Like it if you could. We've got a lot of people that are starting to watch these videos, and this is going to be a good learning experience here, especially on this topic here of measuring. So we're going to start right out here and go over to a tape measure here. I've got one right out here, and tape measure is your first basic measuring tool that you're going to use when you cut your material to start with. Everybody uses tape measures. When you were a kid, you probably got measured to see how tall you were. They used the tape measure there. As you grew, they kept looking at that, and finally the doctor's office had the ruler that they put on top of your head so you could see how tall you were. But every trade uses tape measures. You know, you look at what these guys build houses with, they're using a tape measure and a carpenter square, and they just do a fantastic job with some of the beautiful homes that they've built, but they're working with a tape measure. All the other trades too, electricians, plumbers, pipe fitters, sheet metal workers, they all use tape measures. Anyhow, we're going to look at the tape measure. It goes up to 12 inches and 13, 14, 15, but in this particular one, where the 12-inch mark is, it also above the 12 has a 1 foot mark. And then in red above the other numbers, 1 foot, 1 inch, 2 inch, 3 inches. So you can, if somebody tells you to cut a piece that's 1 foot 5 inches long, 1 foot 5 inches, or they tell you 17 inches, you can get it cut to the right length. So you have to make sure you keep an eye on which number they're talking about and correctly mark it. The 16 happens to be the distance between studs and a wall in a house. Standard measurements there. Anyhow, with that tape measure, that breaks it down to where we're measuring within an inch or a quarter of an inch dimension. But for machining purposes, we're going to talk about how we break down an inch to our decimals, or numbers that we work with on the machines. So we're going to start out talking about 1 inch here. That's going to be like 100%, or in this case we talk in thousandths of an inch. There is 1,000 thousandths of an inch in every inch. If we go to a half an inch, then there's 500 thousandths in there, and there's going to be 2 equal halves at 500 thousandths. 50 cents of a dollar, 50% in percentages, that all kind of equates there. As these numbers here get bigger, these numbers here get smaller. So half of a half an inch is a quarter of an inch, which is 0.250. That's the same as a quarter, or 25%. That's common numbers that we use in our monetary system, or percentages and that type of thing. When you get into smaller fractions, then the numbers get a little bit smaller and not quite as common. An eighth of an inch is half of a quarter of an inch, and so that is 0.125 if you do the math. Half of 0.25 is 0.125. And then a 16th of an inch is half of an eighth, and that's 0.0625. And on down the line. Here's a 32nd of an inch. We talked about a 32nd and how it works out with screw clearances in a couple of previous videos. So 1/32 is 0.031, 1/64 is 0.016. Anything smaller than that, you really can't even see it on a scale. But here's, using the dollars and cents or percentages, these numbers kind of equate to the same type of thing. So we're going to be doing measurements in thousandths of an inch increments. Here's some other numbers that kind of come into play once in a while. If you're talking about 1/3 of an inch, 1,000 divided by 3 is 333, or in this case, 1/3 of an inch is 0.333. 1/5 of an inch is 0.200. If you divide 1,000 by 5, you get 200. I'll tell you in a second where that comes into play. If you divide an inch into 6 places, it's roughly 16%, or 0.160. Now the 0.200 is kind of interesting because I showed you on a previous video that when you move the table on a milling machine, I got my readout is gone to sleep on me here. When you move the table on a milling machine, every revolution of your handle, one full revolution is going to move about 200 thousandths on the table. So that's kind of a handy number to know when you're moving your table. But this brings up the point of why on earth would we convert fractions to decimals. You just saw it right there, the digital readout or the handle on a milling machine. If we look at these little numbers right here, this is the dial on the milling machine. Every line there you see is 1,000th of an inch movement of the table. So the machine doesn't have fractions listed on it there. It's got lines that are 1,000th of an inch apart. And I'll just turn this around. The handle makes one revolution. It counts up to 200. Well, the 200 is a 0 again. So you got 190, 195, 6, 7, 8, 99, 200. So every revolution of the handle goes 200 thousandths. Okay, some of the measuring tools that we typically use are little pocket scales. I've got a scale here, and it's got some pretty small lines on here. If we can focus in on that, this shows 60/4 and 30 seconds. The top is 30 seconds. There's 32 30 seconds in an inch. And you can see how it counts up in 4, 8, 12, 16. You know, every 4 lines there's a number on there. Below that, every 64th is every 8 64ths they have a number. There's 64 64ths in an inch. Okay, so that number, and if you look at your decimal chart, you can see they've got the fractions right there that tells you what they are. There's 1/32 equals 0.031, just like we had on the example I wrote out there for you. On this particular small scale, on the back side of it, that has the inch broken down into tenths or hundredths. So a lot of times when you're machining something, you might need to make something that's 0.8 inches long. Well, you're not going to see it over here, but you will see it on this side of the scale. So that's a handy thing to have on a scale or a ruler, is to have both the hundredths and fractions on there. Here's another scale that it's got the same things on it, except on the back side it's got metrics. And we'll talk about metrics later on here in another episode maybe. But the problem I don't like with this scale, when it gets down to the end, you've got 150 millimeters and then a gap. So if by some chance you would measure from the end of the scale and pick the wrong end, you'd be off probably 3 or 4 millimeters there. It doesn't have an extra length on the end of the scale for inches. That's totally a 6-inch scale right there. It goes all the way up to 6 inches, but the metrics on the back side don't go all the way through. So that could be a point of error or confusion. Okay, going back again to our tools that we use to measure and work with the machines. Everything is calibrated in thousandths of an inch, decimals. So that's why we convert fractions to decimals. It'll be something that's easy for you to see and figure out once you start working on things. That these I'm moving it along here as I'm talking, but here's 100 thousandths almost. It's kind of hard to get it to move. We talked about how thick a piece of hair was, or how thick a piece of paper is. That's 2.5, 3 thousandths for a piece of paper. So that you can measure a piece of paper. Maybe I should do that here. I don't know. I've only got one hand to work with. Prior to digital calipers, and they're very inexpensive nowadays. You can get a pretty good deal on a caliper. Before we had that, we had dial calipers, and that's got like a big dial on the front that spins around as you move. And this particular one here, when I get this up to 0, if I can get it there that close, you can see on the beam right here it says 7. So that's 700 thousandths. Again, each line here on this thing is 1,000th of an inch. So now we're 7 inches 10 thousandths, 7 inches 20, 7 inches 23.5. So everything, once you start machining, everything revolves into fractions converted to decimals, and in between all these decimal numbers are all other numbers, and those are the readings on the machines. So we're going to run out of time here in a few minutes. You got your handy chart here. Get a hold of one of those. You got scales. Get one that works for you. One that these are satin chrome clad, so the numbers really stand out. It's easy to see. The calipers, the dial or the digital calipers are really handy because they tell you exactly what number you're at within a 1/1000th of an inch. So that's pretty good reading. I'm going to give you a couple of little points here too. Another measuring tool that you would use quite often is a protractor. So you're going to be able to check all the different angles. There's things that you have to make on an angle. And while we're talking about angles here, the most common angle is probably a 90-degree angle. It's a square corner. It's not kind of square. If it's 90 degrees, it's right on the money. If you have a triangle where the hypotenuse is 1 inch and you've got a 90-degree corner, the other two corners are both going to be 45 because the sum total of all the angles inside of a triangle is 180 degrees. So in this case, when you've got a 90-degree corner here, and if your leg here is 1 inch long, forever and ever, the length of this side will be 0.707, as will the bottom one be 0.707. If this leg on the bottom is 1 inch, the hypotenuse is going to be longer. You can see the hypotenuse is 1 inch, the straight leg is 0.707, 70% or almost 71%. If this was switched where the 1 inch was down here on these two legs, your length of your hypotenuse would be 1.414, which just happens to be double 0.707. That's the only angle where you're going to have that phenomenon. So, it's easy to, see that 1 inch on the straight is 70% on the leg. Another little trick that might come in more handy too for you is if you are, let's say you're trying to put a building up and you want to get the foundation square, and you want to measure to know that it's square. If you measure 3 inches or 3 feet or 3 yards on one side, and then you make another measurement of the same units, 3 inches, 3 feet, 3 yards, whatever, in order to make sure that these are square, the third leg would be 5 inches exactly. If you go back to the old formula, a squared plus b squared equals c squared, that's what this would be. 3 times 3 equals 9. 4 times 4 is 16, so 9 plus 16 is 25. The square root of 25 is 5. Now, if you don't know the math on that stuff, that's okay. I didn't either, and I learned that by using it. So that's a good example of how to check if you're building something and you want to make sure you're square, or you have something square. It's the 3, 4, 5 rule. So anyhow, I'm going to put another plug in here for the IMTS show coming up in Chicago. It has so much to do with machining, and their wording in there says where dreamers and doers connect. Couldn't be more true. So that's coming up in September here, the 10th through the 13th at this is the 10th through the 15th at McCormick Place in Chicago. So if you get a chance to go, man, you just couldn't be in a better spot to learn about all the things machining related. Anyhow, I think we'll call it a day on this project here. Just a few things about measuring. I wanted to talk about how decimals are a part of our machining. Excuse me. So anyhow, we'll sign off. Be sure to share and like this and subscribe.